right, we are now looking at our KC7 notes. So our first target is target 7.1. I can identify, or apply, shouldn't be the word identify there, we'll cross it out. I can apply the relationship between the degree and leading coefficient of a polynomial and the end behavior of a polynomial. So our first vocab word is polynomial, and a polynomial is simply a combination so that's combination means add or subtract, right? Of terms that have coefficients and variables with positive integer exponents. Could also be zero. So combination, addition, and subtraction of terms that have coefficients and variables with positive integer exponents. So therefore, I can have a variable that's like x squared. That works because 2 is a positive integer. You can't have something like x to the negative third, and you also can't have something like x to the 1/2. Okay, so they have to be positive integer exponents. You have exponents. The degree of your polynomial is the greatest integer, or largest integer. Not integer, sorry, exponent. The greatest exponent in any term. The leading coefficient is the coefficient in front of the variable with the greatest exponent. Okay, so again, it's the coefficient in front of the variable with the greatest exponent. So the degree and the leading coefficient come from the same term. Okay, so you're always looking in the same spot. It's called a leading coefficient because when our polynomial is in standard form, it's first. So standard form is written largest exponent first, and then exponents in decreasing order. So largest exponent first, and then exponents in decreasing order. Alright, example 1, write each polynomial in standard form. State the degree and leading coefficient of each polynomial. If it's not a polynomial, explain why. Well, I'm going to look here. Our largest exponent in A is this 4. Okay, it's already first. Here we have a 2, a 1, and no variable with no exponent, right? Technically it's x to the 0. So yes, this is a polynomial, right? All my shown exponents are greater than 1, or are positive, or greater than 0, sorry. So it is a polynomial. It's already in standard form. My degree, and it's 4. It comes from that largest number. And then our leading coefficient right? It's the number in front of that. So our leading coefficient is 7. So this has a degree of 4 and a leading coefficient of 7. Looking at the 8x squared plus 3x minus 2, this is also already in standard form. So then that first one is going to be where I get my degree and my leading coefficient from. So my degree comes from the exponent. My leading coefficient is 8. Looking at 7, right? So it's looking good because I have 6 and then an exponent of 3, but then I have this 1 over x. This does not work. This is not a positive exponent. 1 over x is the same as x to the negative 1. So you can't have anything where like the x is in the fraction. So this is not a polynomial. So we can't do anything with that one. Looking at target, or letter D, not target D, I want to find my highest exponent first. Well, this is a 2, a 3, and a 5. This one is my largest exponent, so negative x to the 5th. I'm going to use that one. I want to find my next largest exponent. Well, I have a 2 and a 3. This is my next largest exponent. Then x squared is my next largest exponent. Having a fraction as a coefficient is fine. It's not the same as 1 over x, right? Here, it's the exponent that's the problem. Here, this is fine. My exponent is 2. Okay, so just because there's a fraction doesn't mean it's not a polynomial. It's because the x is in the bottom that it's not a polynomial. Okay? So then my degree well, my largest exponent is 5. And then my leading coefficients right? Well, there's just a negative, so that means it's negative 1. Right? All right, let's go ahead and look at the next page. The other thing we're going to talk about today is end behavior, okay? And graphs that have the same kind of degree, and we'll talk about that, and the same kind of leading coefficient, have the same end behavior. Okay, and what end behavior is what the graph does as it continues forever. Okay? So a lot of times, like, we have all these bumps and stuff right near the middle of it. But as I zoom out more and more, all of our graphs will eventually do something forever, and that's what we call our end behavior. Okay? And we have 4 main types of end behavior. Okay? This first one, just like a quadratic, right, a parabola, it's going up forever in both directions, right? Even if I draw like another graph, even if I put some other, I could bump around forever, right? I could still end up going up forever in both directions, okay? And these two graphs are gonna share some properties, and those properties are your degree is even, and your leading coefficient is positive. Okay? So if your degree is even and your leading coefficient is positive, then it will look up and up forever. So how do we write this end behavior? The textbook I copied this from writes it one way. We are actually going to write it in limit notation. So this says f of x goes to positive infinity as x approaches negative infinity. What does that mean? Well, it's really this part we want to read first. As x is going towards negative infinity. So as x goes this way, what's my y doing, right? Again, f of x is the same as y. Well, my y is going up. So as x is going left towards negative infinity, my y is going up towards positive infinity. And again, we're going to write this in limit notation. And we say the limit as x approaches negative infinity of f of x equals positive infinity. So again, the limit as x approaches negative infinity of f of x equals positive infinity. On the other side, right, because there's two ends to a graph, it's going this way. As x approaches positive infinity, what's f of x doing? Well, it's also going up. So the limit as x approaches infinity of f of x equals positive infinity. All right, so that's our first type of end behavior. Looking at our second one, if my degree is odd, but my leading coefficient is positive, what's going to happen with my end behavior, right? Well, now as we go to the left, what's happening to our y? Well, if I follow this left, I'm going to end up going down forever. So you write that as the limit as x approaches negative infinity, because x is going left to my negatives, f of x equals, it's going down to negative infinity. So again, the limit as x approaches negative infinity of f of x equals negative infinity. On the other side, what's happening, again, as I go to the right forever, if I follow my graph, it's going up. So the limit as x approaches infinity, the right, of f of x equals infinity. Up, right? Okay, our next one. Now this one's even, but its leading coefficient is negative. Okay? As I go to the left, it's going down. Right, so the limit as x approaches negative infinity of f of x equals negative infinity. So left forever goes down forever. The limit as x approaches positive infinity, as I go right forever, f of x equals, I also go down forever. So as I go positive forever, the graph is going negative forever. Last one. we have a degree, an odd degree, and our leading coefficient is negative, well, as I go left forever, what's my graph doing? It's going up forever. Up is positive. The limit as x approaches positive infinity, as I go right forever, of f of x, well, my graph is going down forever. Okay? I think the most confusing part of these is the notation, but as you practice it, you'll notice we almost wrote exactly the same thing for all of them. The only thing that's changing is they're positive or negative for polynomials. Okay, so for the most part, our polynomial end behavior is very similar. Okay, so we kind of got to memorize how we write this notation, but then you're just changing this. All right, last thing we're going to do is just look at a few examples here. So for each graph, describe the end behavior, determine whether the degree is odd or even, and determine if the leading coefficient is positive or negative. Okay. Well, we're actually going to do this part first, and I'm actually going to look back at these. So how do we determine if the degree is even or odd? The easiest way to determine whether it's even or odd is to look at both ends. If it's even, notice on the evens, both ends go up or both ends go down. So when it's even, both ends are doing the same thing. Where if it's odd, both ends are doing opposite things. One up, one down. Okay? So looking at this first example, both ends are going down, so I know my degree is going to be even. Then, I want to know what my leading coefficient is. The easiest way for me is I look at this side. If the positive side is going up, it's positive, right? On the positive side, well, if they're positive, this right side is going up no matter what. When it's negative, the right side is going down no matter what. Okay? That's how I decide if it's positive or negative. So if I look at this one, my leading coefficient, right? My right side is going down towards negatives, so it's negative. So when I write my end behavior, this part is always going to be the same. The limit as x approaches negative infinity of f of x equals 1. So as I go to the left, what is my y doing? It's going down. That means negative, and it's going down forever, negative infinity. The limit as x approaches infinity of f of x, again, that part's always the same, equals what? As I go to the right, what is my graph doing? It's going down forever, negative infinity. And that's it. Let's look at this one, degree. Well, again, degree, if they're both the same, it's even. If they're different, it's odd. Well, one's going up, one's going down, so this is odd. Coefficient. Again, I look at what's happening on the right. The right is going positively up, so it's positive. Okay. Writing our end behavior. The limit as x approaches negative infinity of f of x equals, right? Well, as I go left forever, my graph is going down forever. The limit as x approaches infinity of f of x equals, as I go right forever, our graph is going up forever. Last one. Degree. They both are going the same way, so our degree is even. Our leading coefficient, well, the positive side is positive. Right? And then our end behavior. As my graph goes left forever, so the limit as x approaches negative infinity of f of x equals, as I go left forever, my graph goes up. As I go right forever, right, as x goes towards the positives, my f of x is going up. Right, my graph is going up. All right, and that is it for end behavior. Have a good rest of your day, and I'll see you guys tomorrow.